For the third category of testing tools or for mobile test, as I know, the Appium testing tools is the most famous testing framework for mobile applications, and there are numbers of other testing tools that you can search and learn how to use them in testing your mobile applications, as well as other type of applications. I talked about them in previous categories. But for test management tools and defect management tools, there are some other tools like as Bugzilla, IBM Rational Clear Quest. Maybe some of you be familiar with some of these tools, and there is a famous testing tools, test management tool that is not considered in this slide, the Jira, G-I-R-A. The Jira testing tool is another famous testing tool that that is used for test management activities or defect management activities. Okay, you can see the demo of these tools from their vendor sites, and use other materials such as videos that are presented in YouTube. Okay, if you have questions, please ask your questions about these tools. You can select one of these tools. Each of you can select one of these tools and search about how to install, how to use these tools in practice, and make a representation for each of them about in about 15 minutes. A short introduction to using these each of these tools. This could be consisted of your instead of doing the several exercises or the exercises at the end of each chapter. Okay, no problem. Be cautious. I want to take exam in about the concepts of the concepts that presented in the class in the entire of this semester, and you can do this for extra marks. You can do this activity for extra marks, no problem in this area. Let me go back to our slide, but before we return to our slides, we ask again session we can have representation of you. If any one of you is ready for doing their representation, doing him or his or her representation, no problem, you quit this session. We have no any more time for your representation when we want to represent your study project. I don't know when you want to doing your representation. I can cite there 6 marks for your representation and 4 marks for implementation of your research papers. In case of review papers, you can select one of these tools for 4 marks. When you want to do these activities, I have no time. Some of you have sent the video of their representation, but it's not acceptable because we want to discuss about your problem, about your solution, about your analysis of your results in the paper, and we want to discuss about new notions or new issues at your selected problem in this class, in the class. The explaining the paper has 6 marks, as I told you, and its implementation has 4 marks. They have 10 marks. I want you to start your representation at next session, and the time could not be extended more. Okay, if no one of you is ready, I continue to our course. As you know, in a previous lecture we talked about how to extract control flow graph from source code, and we talked about several structures such as if structure, if else structure, loop structures, and we we have explained how to extract control flow graph from these structures, and as you know, we reach to the if I remember true, we reach a slide. Okay. This slide says about how to create a control flow graph for do loop structure, and talk about how break statement and continuous statement change the flow of control of our program, and let me to explain each of them according to suitable examples, suitable pieces of code. Suppose we have a program such showed in this box, in this code. First of all, x is initial 0, and a do while loop is used in the body of the loop. We have two statements, two assignment statements, and the while is conditioned by this Boolean structure, this logical structure. And finally, a return statement is used to return the value of y variable. How we can create a control flow graph for this piece of code? First of all, we should find a location numbered y to do this statement, to let x to be 0, and then we should go to the next to another statement to doing the do while, the statements of do while loop. As you see, the statements that should be run at this location are these two statements. Then we repeat these statements if x be less than y. So we have a self edge, we have a self loop. If x be less than y, these two statements will be repeated again, and this will be continued until the x be greater than or equal y, such as this showed in this edge. And at this situation, we go to another location, such as location 3, and at this location we run this statement, we run the return statement. So this location will be a final location or final state. I hope you learn clearly how to create control flow graph for do while loop, and let me to explain how break and continuous statements can change the flow of control of our programs. As you see at this next example, we have a while loop in which we have used a break statement and continuous statement in its conditional structure. First of all, when we enter to the while loop. We set y by the value of return value of the function f. By this function call, we calculate the value that should be stored in y, and then if y be 0, we should break the while loop and go to the return. Else, if y be less than 0, we set y to this expression, the result of this expression, and then continue. When we execute this statement, control of the program go to the while again and start by executing another time the loop statements. Okay, so let me draw control flow graph step by step. In the first step, as you know, we should have a location that set x to 0. In the next step, we should go to the dummy statement, dummy state or dummy location to start the while loop. As you learned in previous lecture, for some loops such as for loop or such as while loop, we should define some dummy statements, dummy states or dummy locations to define the control flow graph for these structures properly. So at this state, we start to entering the while loop, and we should check the condition of the loop, and so we have to branch. We have to branch from this statement. So the first branch is when the condition of the while be violated, when x is not less than y. So the condition is violated and condition returns false, and we skip the while loop and go to the return statement. The return statement defines a final state, defines a final location. On the other hand, when x be less than y, we go into the loop and run the body of the loop in a proper way. Let me go to the loop. In the first step, we should execute this state, and then we should define a branch for if statement, such as this. When y be 0, we go to this statement, which is a break statement. As you know, when we break a statement in a loop, we go out from the loop and continue to the body of the program just after the loop, such as this. When a break statement be executed, we go out from the loop and go to the statement just located after the loop. As you know, the end of this while loop is at here, and the next statement will be return y. So the break statement can change the flow of control to go to the return y. Otherwise, we check the y according to 0. If y less than 0, we continue to execution of this statement and then continue the loop. Next y for the new y. Okay, so else if y be 0, we go to the break. Else we should check again y according to the 0 number, such as this. At this state we also have a branch condition. One branch, let me see, one branch go to the continue, go to this statement, and the other one go to this statement after the if else structure. The first branch is taken when y be less than 0. When y be less than 0, these two statements should be executed at this. And as you know, the continue change the control flow to the entrance of the loop next time. So the continue go to the starting of the loop, and if y be greater or greater than 0, we should go to this statement and then come to the first statement of first state of the while loop. So otherwise we should execute this statement at this state and come back first state of the loop. Okay. So you have learned about how break and continue statements change the flow of control, and how do loop could be used in control flow graph. Let me see your message. Yes, there are two conditions. There are two conditions. The first condition is this one, and the second one is this one. So we have two branches. One at this state and one at this state. Okay. Another structure that should be modeled in control flow graph is structure. As you know, when we have several conditions, our conditions should be of equality type. We can use switch cases in our programs. For example, in this piece of code, you see that we read variable c from input, and we should compare the value of c with several specific values such as n, y, and other y's, and in each type we should do its own statement. For example, when c be n, we should assign the z to be 25, and when this character be y, we should assign the 15 to the variable x, and then break to go out from the switches and go to the first statement just located after the switch case structure, and otherwise the default portion of this structure said us that when C be not N and not Y, then we should execute these two statements. Okay, let me to draw the control graph. First of all, we should read the character C from the input, and then we should compare this character with N, with Y, and otherwise go to the default. So if the character C be equal with N, we go to this state to run this statement, and then as you know, as you see, there is no break statement at this point, so we go to the next case automatically. We go to the next case. The next case is when the character C be equal of Y. Okay, when C be Y, we go to this state. Okay, then at this state we let X be 15, and then go out from the switch case. We execute this statement and break statement, go to the next state which run this statement, print X, and this statement according to this piece of code is a final state. Okay, and when the character C be have other values except Y and N, we go to the default of these statements. These two statements could be executed, should be executed, and then the break statement take the control and go to the 5 state. Okay. And what about the exceptions? As you know, we use a try-catch exceptions, try-catch structure to handle the exceptions, various exceptions in our program, such as this one that we use to catch a statement. We use a try-catch for IO exception and extra exception E at this piece of code. So in the try block, we read and store it to the variable S. Then the length of S be greater than 96. We should throw a new exception to them. And if the length of S be 0, we throw another exception which say that is too short. And in the catch block of this code, we catch two type of exceptions. The first one is IO exception. The IO exception could be thrown when, for example, this file handler be null. When this file handler be null value, has null value, so we can see IO exception. And when the IO exception is thrown, this print stack trace should be executed, and otherwise in two other cases, such as exceptions for too long line or too short line, should be handled at this location. We return S if S be a null value. Let me to see the control flow graph. As you see, in the first state of the control flow statement is run, and then we have a branch to check the length of S with 96. If the length of S be greater than 96, excuse me, we start, let me see, because if this handler of file, for example, be null value, an IO exception could be thrown by this method. So at this state, this location, we have a branch, the one for a usual call of read line, another one for call for a null object. So an IO exception could be okay. And when we go to the usual state, such as 3, then I can check the length of S variable according to 96 at this, and when this condition be true, we throw an exception. Else we should check with 0. Okay. So in this state, we go to the throw exception at new state, and otherwise we go to another state for executing this condition, this conditional statement. If length be 0, we throw new exception again in state 7, and otherwise return. Let me, otherwise related to this edge, when length be not 0, not equal to 0, we go to return. Or at this stage, when an exception was handled at this situation for this statement, we go to return a statement again. So this could be happen at this state and this 1. Okay. This slide show a complex example catch exception in which we have several exceptions, such as IO exception, by which is implicitly be thrown by this method call. Exception is implicitly defined by this method call, and two explicit exceptions in these two structures, and then we have two catch exceptions, two different catch exceptions. So this example is not so easy, and this is a complex example. Let me see. Return the try catch. No, the try catch, the catch part should be handled. It means that, for example, we should print some messages on console, or should process the exception by making extra computation. So the catch portion is not equal to return statement. The return statement defines a final state, but the catch exception statement defines non-final statement state. Okay, they are different. The try catch and return statement are two different structures according to control flow graph. So let me explain a complete method to see how we make a control flow graph. As you see in this method, we have a parameter, a number parameter. As you know, parameters defines some variable, defines some input. So this could be considered as a defined statement, as a diff statement in data flow graph. I use it later. In the statement, the length of this array is stored in the length variable, and several variables such as var, this is a variance, this is a median, this is a standard deviation, this is sum, and var some variables at the second statement. At the third statement, is initialized by 0. As we know from previous slides, these all three should be considered in a state. So in the first state of the control flow graph, we should execute these three statements at the first location. So let me see. In the first location we have these three statements. Then we should go to the for structure. As you know, in for structure, an index I should be defined and initialized O, then I should be compared with length. If I be less than length, we go into for statement, for structure, and we should done all the statements in the for structure. Then we should increment the index of the for and go back to the conditional statement of the for structure to check if I be less than length again or not. If it be true, we're going to again and repeat the body of the for loop, and otherwise we go from loop and continue to the next statements of the program. So we should define the for structure in our control flow graph by defining a new location to set x of the for loop to 0, and then we go into the for loop or skip the loop. So the statement, we have a branch for one for the situation when I be less than length, or one or otherwise. So the conditional statement is checked in this. This is a dummy state in our control flow graph, and when we go into the loop, we should execute the body of the loop at this state, and then come back to the loop. When we come back to the loop, we meant the index of the loop, and then compare it again with the length variable. Okay, and when we go the loop, we should run these three consecutive statements, these three sequence of statements. The first one set the mediation of a number to the element which is located in the middle of this array, and the mean of the numbers should be calculated by the summation of its elements slash the length of elements, which is counted by the length variable. So the mean variable could be calculated by this, and the var sum is initialized by 0 at this statement. All of these three statements should be executed in a next location, say location 5, and we can continue by executing the next structure this as the same as the first loop structure. For doing, should define a dummy state for initializing the index I, and then loop and calculate the var sum variable at the state 7, and then come back, increment, come back condition of the loop to check if we go to the loop again or go out from the loop. When we go away from the loop, we should execute all of these block. This is a basic block that's considered for loop, and they are be done in this location. This control flow graph, as you see, is augmented by some labels for its nodes and its edges. For example, this node is augmented by this label, which says that the initialization of index should be done at this location, and then it should be checked in the next location. So in this we have a branch condition and define two branches, as you see, and uh, labels considered for other nodes and edge. Let me see your messages. This is of too long. Let me read them after the class, after the lecture. Excuse me. So, according to this control flow graph, now we want to define test requirements, and then we define a proper test cases to cover the test requirements. So we have this control flow graph, and for the coverage criteria, as you know, as edge coverage, we should cover all edges of this control flow graph. So the test requirements for edge coverage be all of these edges. The edge which started from node 1 to node 2, node 2 to 3, node 3 to node 4, 4 to 3, 3 to 5, 5 to 6, 6 to 7, 7 to 6, and 6 to 8 are all edges of this control flow graph. All of them are our test requirement set for edge coverage criteria, and we should define some test passes to cover all of these test requirements. As you know, when we have a test case that run according to this test pass, one loop, each loop once, to execute each loop once, at least once, we can cover all edges. So this is a simple pass which cover all our test requirements. As you can see, this pass 1, 2, 3, 4, 3 again, 5, 6, 7, and 6 again, and then go to 8. As you see at this array, at this list, can cover all edges of this control flow graph. This is a simple coverage criteria, and by one test case we can cover all of our test requirements. And another coverage criteria we have learned in this class is edge pair coverage. For edge pair coverage, we should define all possible edge pairs of this control flow graph as our test requirements set, and all of them could be 1, 2, 3, 2, 3, 4, 3, 4, 3, 4, 3, 5, 2, 3, 5, 5, 6, 7, 5, 6, 8, 6, 7, 6 again, 7, 6, and 8. All of these edge pairs should be considered as our test requirement for edge pair coverage, and we should define some test passes to cover all of these test requirements. As you see, there are 3 test passes that we should check to cover all of our test requirements. The first one, as you know, we go from node 1 to node 2 to 3 to 4 to 3 again. So in this test pass, we do the loop once, and we have a side tree. we have a site tree from edge C to edge H. All of these edge pairs have names by some characters. Each edge pair is defined by a character, has a name. The edge pair C and edge pair H is used as site tree for the first test pass. The edge pair C is this edge pair 3 to 2 to 3 to 5. Keep the loop, and the other edge pair H defines this edge pair. When we go through this edge pair, we skip this loop again and skip the side strip. We have two side strips in this control flow graph, and they could be skipped by these edge pairs and this edge pair. Okay. This edge should be covered at next test passes, like the second one and the third one. And if you check, you will see that the first the test pass can be covered by the as I guess by the third test pass. The third again covered all test requirements that are covered by this test pass. This test pass could be omitted from our test passes, and we have just two test passes. We should two test cases to go through these test passes. The other test coverage criteria is prime pass coverage. For prime pass coverage, you should count all prime passes from this control flow graph. As you have learned from previous lectures, they are listed in this box, and there are some test passes for covering these prime passes, and they are mutually evaluated against each other to delete or omit extra test passes. As you know, in practice, the control flow graphs could be very complicated, very distance, and counting all test requirements could be hard manually. So we should use some automatic and to guess the proper test passes to cover these test requirements. I want to do some applications from Jeff Offutt website to do these tasks. Before I go to the website, message who decided the length of how is the length of test requirement? The test requirements requirements could be defined by the control flow graph. The control flow graph determine the control flow graph set defines a set of test requirements in each of coverage criteria. So the number of them are not optional. They could be defined correctly to a specific, because there are no optional tasks in determining the test coverage test requirements. They are strict. Okay, let me go to the professor of C to show you a number of web applications which could be used in defining test requirements and defining test passes. I search introduction to software testing. Introduction to software testing with Jeff. This link is that we want to go to the home page of the book. There are some support software to concepts of the first one is about graph coverage web application, the second one is about data flow coverage web application, and so on, areas for all other structures such as logic and DNF and others. We want to go to this page to see how to use this web application to extract our test requirements according to the graph. As you know, the graph is this one, and we should inform the graph to the tool and extract several test requirements according to several different coverage criteria. For informing the control flow graph to the graph, we should define all edges of the graph automatically determine how to shape the graph. So the edges include edge 1 to 2 to 4, 4 to 3. We want to enter some of them. The edge should be entered such as the first node space, then the second node, then node 2 to node 3, 3 to 4, 4 to 3 again, and then the other edge, as you see, 3 to 5, 5 to 6, 5 to 6, and then let me see, 11 to 6 again, 6 to 7, excuse me, 7 to 6 again, and then finally the final edge is 6 to 8. As you see. here. Okay, so this is the set of edges define our graph, and we should define the initial node and the final node, the only initial node of our the first node, and the final node is the node. So we define the node 8 as final node. So by these three boxes, we have defined our control flow graph. These are all of our edges, and this is the first state, and this is for final state. So as you know, we have several coverage criteria on graph concept. We could define the node coverage criteria, the edge coverage criteria. These two are simple, but defining the edge pair, simple passes and prime passes could be difficult. We can use two algorithms defining passes to cover the coverage criteria. For defining the test requirement, TR, we use this button for showing the all edge pairs of the control flow. As you see our graph, you can change the position of these nodes to show them properly. This could be the same as you see. Okay, this shape is the as this control. Okay, this is similar to our control flow graph by all edges of graph. The tools construct our control flow graph times 12 requirements for edge pair coverage. All edge pairs are below this section for edge pair coverage. You can see simple pass test requirement, prime passes, as well as you see for edge pair coverage. So we want to have test passes to cover all of these test requirements. To have test passes, to show test passes, you can use these buttons to generate test passes to coverage each test requirements of each coverage criteria. As you saw, all edge pairs are these 12 edge pairs, and to cover edge pairs, we push this button to show the necessary test passes. As you see in this table, we need 3 test passes to cover all edge pairs. There are 2 test sets. The first set is shown at this box, and the second one is shown by this test box, and then by this box. You see that, as you see, this table shows each pass and what test requirement could be covered by a test pass. Okay, this test pass covers all of these test requirements. If you check this test compared with the test requirements that are pushed, that are covered by the test pass, you see that this is common with the previous one, and this is possible for edge pairs. Okay, you can use this web-based tool to generate prime pass coverage. For prime pass coverage, we should use more test passes. As you know, two algorithms are these tasks, the algorithm 1 and the algorithm 2, and there are some illustrative statements for describing these two algorithms at this part of the web page. You can use it and see different test passes for, as you see, the second algorithm defines more test passes to cover all passes. Okay, so you can use this online web tools to generate your measurements and test passes according to your test requirements for each control flow graph. As you know, these algorithms are so fast to generate test passes, and no need to do them manually. The time is over. Your messages again, especially the long messages. The link this page several times previously. You know this to this page, and there is no need to send them. You have downloaded your PowerPoint slides from this home page, and in sections of this home page, these tools are described and informed to you. We find the best pass. As you know, I talked about the passes, the test pass in previous lectures. As you know, this problem is not decidable. It's impossible to assert some test pass be the test pass, especially test pass, especially in the presence of loops, of several loops, internal loops, and so on. Okay, let me read your long messages. As you know, and the rest of the professor, but the sound on the platform is not clear, especially when the mic is open. So all the professors upload assignments, projects. Excuse me, I talked enough about this problem in previous lecture. So we ask you to put the assignments and projects on the LMS and so that we can rise that. I'm sorry I explained this point several times, and you represent your works lively online. I want to ask you several points your research paper. I believe that those questions we will learn and study more deeply in future, especially in your thesis, in doing your thesis. And I have several other students in Iraq now. They are that all of them used your infrastructure again to explain their projects, to illustrate their representation, and we hope we have no problem with them. They come from several states of Iraq, such as Kirkuk, such as such as Khanaqin and Diyala state. I have no problem with them. All of them uses the same infrastructure to represent their works. If you want, we can use the Skype infrastructure or Google Meet to set our works. I want to have an oral exam. It's not acceptable doing them offline. We have experienced several problems in doing offline example. Most of them, excuse me, I'm sorry to say this sentence, most of them copied the homework from at this time we have received two homeworks from your friends copied. They copied from each other. Just the name of the student is different. I want to show those homework to you, but I don't want to show the name of your. It's not acceptable for me to have offline exam, offline homework, and I want to have an oral exam. We all should turn on our webcam each other for the first time. It's not possible for me. Excuse me, I'm sorry. Please write anything, ask for project or assignment. I've announced several times our assignments. The exercises that at the end of each section of your book, or at the end of each chapter of your book, all of them our exercises. You should done all of them. You should learn these concepts deeply. In your exam, I open your PDF, your ebook, the textbook, and I go to the exercises arbitrary and ask you some concepts. And as I told before, I have introduced you to video materials from YouTube. You can use these materials to support our if I have not taught very fluently and you have my speaking, you can use these lectures. For example, for lecture, you should use this part and this part of these lectures. This lecture is done by a prestige professor from India, and all of them about our textbook. You have no problem to learn these concepts. I don't know why you afraid from our exam and from our live representation, online representation. You should practice them because you should start your thesis soon. You should defend from your opinion, from your ideas. There is no reason to skip the exam and doing offline homework. You should do them soon, and we should start your representation. Have no more time, no longer time to prepare yourself. If you had the trouble with this structure, these elements, you can use the Skype infrastructure. We can use the Google Meet possibility to have more proper session. If you have more problem, please explain me at this time. I don't see a reasonable, a logical reason to postpone your representations. I have defined your representations at the first sessions, and you have enough time for doing your homework. I have not got a notable activity from you till now. So I want to have a standard exam. I want to have a standard study project and other activities such as explaining the software testing tools as I indicated in the first there is no longer time. Okay. I hope all of you be healthy and have a good day. Goodbye till next session. في أمان الله.